Hi, my name is Edward, and I'm here to help you with your homework for MA 183. What you're going to need for this homework assignment is going to be your Geogebra file with your Skew Pantograph mechanism, and then your SolidWorks program. I hope it's up to date, otherwise you won't be able to open past versions. And lastly, you'll want a snipping tool or some other note-taking software, whether it's just your paper or notepad. For this first part, I'm going to open up Geogebra and SolidWorks, and I'm going to take a screenshot of my file and put it onto SolidWorks. So one of the first things we're going to do is open up your snipping tool or screenshot of source. You see I already had it open from before, and here I'm just going to select new and take a screenshot or a snippet of the part that I'm going to measure out. So this process is very important because we're going to use SolidWorks to get the dimensions of the parts that we're going to create. After you have the screenshot, you're going to go into your SolidWorks and you're going to open up a new sketch. And then I'm just going to hit spacebar, select the plane, and then I'm going to copy and paste this in there. So now I have my screenshot in the picture. I want to make it a little bit larger and center it. Hold on, misclick a little bit. So I have my model right here, and now I'm going to begin actually measuring the parts out. So before we begin, I've minimized Geogebra and my snipping tool, and now I'm going to have just this notepad open so you guys can take a look at the steps I'm going to go through. First, you're going to want to draw the points on your sketch. I'll show you how to do that in a moment. Then you're going to connect the points, measure, and make note of the important dimension lanes. After this process, we're going to go into making each individual part, and then lastly, you're going to put everything together into your assembly. So as I said prior, the first step I'm going to go through is adding individual points. These points are going to go on each of these respective linkages where each part will essentially have a point of connection or form the solid. I will speed through the process of me actually doing it so this doesn't turn into a giga-long video. But if you have any questions, you can feel free to contact your professor or utilize the discussion boards. So now I've put all the points on there. You may not be able to see the points after I've actually clicked on it. That's because they're going to be removed once I remove the picture. Or sorry, they'll be visible once I remove the picture. So let's take a look at what that's going to look like. I'm going to first exit the sketch. I'm going to click this picture. As I pulled it away, you'll notice that the points are right in front of the screen. So on the screen in front of you, I've pulled up my GeoGebra model that I used for this project. And you'll see that the motion of the crank as it's going through 360 degrees moves the different parts. Looking at this simulation, you will see that there are individual parts that you should be modeling, and this is how we're going to learn what linkages and sections we're going to measure using our SolidWorks sketch. So you'll see here on the screen that there's this crank, and as it's rotating, it has 1 and 2 solid bodies moving, and then it has 1 and 2 linkages that are essentially holding this up as supports. So there is this linkage that connects these two fixed points that are the light blue or dark blue, whatever it looks like to you, lines. This will not be modeled because these will just be attached to the base of your robot or walker. In this case, we'll just have a solid base so you can see it in action. So one of the first things you're going to do when defining dimensions for your part is actually arbitrarily choose one. I'm going to start with the crank length, and I've arbitrarily decided 3 inches or about 75 millimeters. I'm just going to leave that as a note in my notepad. From now on, I'm going to start dimensioning the other items. Now one thing I am going to do is for this dot right here, I'm going to not delete it, but I'm going to make a note that this dot is actually not relevant in the design of my part. And I'll break this down a little more in detail later, but I want you guys to see how I do this first. So first I'm going to smart dimension here to this point. This is going to be 480.22 numbers. Okay, so I'm going to copy this down into plate 1, and I'm going to, under plate 1, I'm going to put long, put a space to identify. So long will be this length. I'll hit a checkbox here. And then I'm also going to smart dimension this length here. Now make sure it's not skewed like this, but rather you want it to be a direct line and the measurement of the direct line between the points you're measuring. So this is going to be, oh, let me get back in that sweet spot, about 302 millimeters. And again, this can be a little flexible, but this is going to be just a breakdown of the different lengths of these parts. So this is going to be my, I'll call this side 1. It's not the long side. And then I'll also have a side 2, which I'll measure in a second. So this smart dimension here is going to be, oh, can't click it correctly. I'm just going to delete this. Bear with me here. So I'm going to smart dimension these two, and I'm going to create this. And this is going to be to about 278. So now I have the measurements for my first plate. I'm going to hit this checkbox. I'm very happy with that. I'm actually going to now delete this so it doesn't get in my way. This is also why I have these documents measured here. Now, I've got this triangle measured out. Excuse me. I'm now going to measure this larger, not necessarily larger, but this other triangle. So I'm still on smart dimension. I'm going to measure dimension number 1 here. I'm going to put that in here. This is going to be my long side again. And then I'm going to have short 1, short 2, and we'll just put those measurements when we get those. So now to measure this length. And then I'm also going to measure this length. That's not correct. There we go. All right, so now I've put all these lengths on here. One thing you can do, especially when these lengths are quite similar, is take a screenshot of that dimension of the triangles you're actually measuring out. That way it's a little easier for you to recreate when you make the parts. Lastly, now I'm going to delete these 3 again because I no longer need them on my screen. I'm going to measure out these 2 supports. So again, this top support here is support 1, and this support over here is support 2. So I'm going to click here to here, measure that out. That's going to be 211. And then I'm going to just exit out of it, delete that, and now I'm going to get this measurement, about 301.43. And then lastly, and this one is important enough for you to consider actually, is I will measure this distance out. And first I want the horizontal distance. So I'll call this distance between fixed points. And then my X distance is going to be this much. And then my Y distance is going to be this much. Knowing this will allow me to correctly reference these fixed points when I put it on my base plate. So now I have these points measured out. These have served me well. I will not delete these. I'm still going to keep this sketch and picture here. I will save this as its own assembly or its own part, so I can always reference it later if I need to. Now, before I can make any of the parts for my Skew Pantograph walker leg, I need to know the size of the holes that I'm going to use for the connections. Now, this is the brass tubing that would have been made available for you when you build these in person. I'm just going to go to the Evaluate tool, and then I'm going to select under Evaluate Measure. I'm going to select the outside radius or the outside face of the brass tube, and here it's going to show me the area, perimeter, and diameter. So most importantly here to me is knowing that it's a 6.35 millimeter diameter tube. So I'll say tubing here, and then diameter is 6.35 millimeters. This way I know to make the inside face or the inside connection points of my parts 6.35 millimeters. Alright, so to amend my measurement earlier, we do have an inner diameter measurement taken on the tubing. However, we will make it a little larger to fit the bushings, and with this little outer diameter is going to be used to make the part a little more sturdy, and this link width is what will allow us to make our final dog bone shape, and this is going to be in the files if you choose to use the ones I built. So the following video, which may be muted, will just be me working through how I actually built these components. If you yourself want to, to get a review or a refresher, see the mistakes I make, show that I'm human, that's entirely up to you. But here I'm just going to start with the first item, making the crank length of 75 millimeters, and I'm just going to start going with it. Alright, so here I have just kind of gotten my endpoints. I have not defined any of the distances or the sizes. I'll do those in a second, but you'll see me creating the relations between the sizes just to make things a little bit easier for myself in the future. So this distance is going to be the crank length, which is going to be 75 millimeters. As I have highlighted here. This is going to be the outer diameter of the tubing, 19.66 millimeters. And this inner diameter is going to be the size of this inner diameter here, which is 9.83 millimeters. So this is what I'd like this sizing to be, and the last thing I'm going to use, and you'll see some overlapping parts here, is I want to use the slot to create my link width, just because it's going to be a little faster than an alternative method. So I'll look at this radius, and this radius, which is going to be this half, will be half of the link width I want, which is going to be 6.35 millimeters. If I did the diameter, ergo this measurement from here to here, I misclicked there. From here to here, you'll see that is 12.70, so you know we did that correctly. I'll just define that and cancel it. So now this is ready to be extruded. I'm going to exit my sketch. I could have deleted some lines, but I'm going to do this a little bit faster, so you don't have to. I'm just going to define the parts that I want to extrude right here. So you have this out like this, and then it's going to be a 1/4 inch thick, so it's going to be 6.35. Oh, maybe I typed incorrectly. It's going to be 6.35 millimeters, and there we go. Also, if you want to see how we get there, open up a new window here, just to get 1/4 inch to millimeters is 6.35 millimeters. There you have it. So that's going to be this part. We're going to change the colors. You can do this on your own later. I'll modify this later, but just to show you how to change materials or appearances, you can go into materials right here. I'm going to click edit materials, go into the wood section. I'm just going to select pine for right now. I'll change this off screen later, and there you go, have the part. So now I'm going to save this. I'm going to save this under the self-made, because I made this myself. This is going to be my crank. That's one part down. Let's exit out now. I'm going to start working on plate number 1. For this plate number 1, I actually don't need to open a file. I'm going to click new file, set my measurements, MMGS, and then I'm going to start making it again. So this is going to be my triangle here. I'm going to use my triangles to center my part, and then that'll give me the locations for my dots. As you'll see here, I'm drawing the lines, so it's going to be a little easier for you to see. So I've set a random triangle here. This will be my long side. I'm going to make sure that it's actually the distance parallel to this part. This is going to be 480 millimeters. Copy and paste that in there. This dimension, that's incorrect. I'm going to delete that. This smart dimension here, I'm going to arbitrarily pick a side because I can always flip it later. And note, you are going to need to dimension every single one of the sides, because I made this perpendicular on accident, so I'm going to go back here. I accidentally selected one of the lines earlier to build this on top of, so I'm going to delete this perpendicular relation. And now I can dimension this and actually make it what it should be. So it's going to be 278 millimeters. Going to copy the entire thing. And there you have it. This is going to be my dimension part. This is what I'm going to use to reference my circles, and I'll delete it later. So the points should all be here. I'm going to use my hole tool now to create these concentric circles. I'm going to arbitrarily give these a length. And then I'm going to set relations again. So I'm going to control click all of these. And these are going to have the equal sizes. And just to save myself some time later, I will also do the outer diameter right now. And I'm also going to set those. I did not mean to exit sketch there. That is not what I should have done. So I'm going to exit back in, or not exit back in, click back in. And I'm going to set the relationships now between these outside circles only. And these arcs should all be equal as well. So now when I change these size settings, you'll quickly see what it should look like. Now that I have this, I'm just going to delete these center lines because I no longer need them. It does still keep the relationship between these center points, which is what these circles are built on. I'm going to define these with my outer and inner diameters again. This is going to be 19.66 millimeters. That changes everything you'll see now. And this here will be, I didn't click on the wrong circle. This is also incorrect. This should be the inner diameter, which is 9.83 millimeters. This outer one here is going to be 19.66. Not everything I do is the best conventions. Here it's mostly for you to be able to see it yourself. And then here I will start making my slots. I'm going to select straight slot, select here on the center. And then I'm going to make this, I'll fix these dimensions later in a second. Right now I'm just arbitrarily clicking just to make these slots. Give the center hole, and I'll give you a random distance, and I'll smart dimension to make all of these. So this radius is going to be the same as the half of the outer or half of the link width I have here. So again, 6.35, that should be a 1/4 inch. Radius. So I'm going to do that with all of these segments. Here I'll show you how to do it if you wanted to just use the center line. This will be 12.7 millimeters. Going to be the same size. And lastly, I'll do it here. Right, and here I'm going to extrude it. I'm going to go to extruded, boss, and base. I'm going to select this. Now, if I just did this alone, it would come out with errors. So I'm always going to use a selected contours here. And then let's start selecting it. So this one's going to take a little more clicking. I could fill in the insides if I wanted to, but just for the sake of this, I will not right now. That's something you could do though, as an option. So I'm going to select all of this together, and I selected that on accident. All right, so this should all come out. I'm going to make this 6.35 millimeters and click check. Clearly I misclick something here. That's one of the dangers of having all these sketches and contours together. It would behoove me to delete some of these lines, but alas. So I'm going to zoom in a little more now. Hopefully I just select faces and I don't over select any items. And here I have these parts. I think that should be defined there, and let's see what it looks like. And there we go, the part has come out. If you wanted, of course, I could select the inside area. That's something you'll have the option to do. I will select these materials and go from there. So I'm just going to keep it pine, but I'll change the color so it's a little easier to see in the future. I'm going to save this, just going to keep the name so I can reference it later. This is going to be my plate number 1, and I'll exit out and start the next one. So I'm going to repeat this process. I'm going to talk less now that I've gone through these parts, and change my settings and just continue. clicked exit sketch on accident. Just gonna click X on that so I can continue editing this. I'm gonna add my circles now and continue what I did before. I'm gonna add some relations. Make all that equal. And now I'm going to do the same again with the outer circles. Of course, still a little mishap there. That's okay. That's why Control Z is your friend. And then now I'm going to set these relations again. So click the arc and then Control Select. Make sure you don't Control Select the wrong bits. And then set this equal to each other. Now I'm going to smart dimension these for sizing. So this is the outer diameter. Outer diameter is 19.66 millimeters. By now you should be able to find this on the paper or the notepad I have on the side. Inner diameter will be 9.83 millimeters to fit the bushing. Now you see all the circles are here. I'm going to exit out of smart dimension and start deleting these inside lines. And here is where these slots come in again. So slot here. Also, I realized I can actually just define the slots to each other, which is something I'll do for, or at least try for this one, make sure it does work. So I remember arbitrarily giving the slots some sizes. Excuse me. And then I will come out here and set these arcs all to Control click and Control click. And I'm actually going to clear all these selections because I realized I accidentally selected some extra items. So I'm going to select all these arcs again, at least these outer arcs. I'm going to set them equal to each other. And these do not have a defined length yet, so I'm going to go in here and define this inside diameter as my link width of 12.7 millimeters, and now they should all be the same size. This creates that dog bone shape we're looking for. Again, if you wanted to, you can also fill in the inside. That would make it a little easier. Here I'm going to select the sketch that I want to do. Get a better looking face after I apparently fix this. Again, 1/4 of an inch thick. And now I'll get the correct face that I'm looking at. Delete this contour and start selecting items. This here. Get rid of that inside area. Don't want that. All right. Select that, and then lastly these tidbits. You can see that I have the preview on, so it'll show you what the model generally should look like, and this is going to come out fine. This here I accidentally selected the circle, so I'll just go back in here, and then I'm going to go inside on look from this top view and just click the center circle. That should remove it, and voila, there we go. So I have this now, and I will go in here, change the materials, edit material, and go back to my pine wood. This is going to be my my second plate. Save it as plate 2. Exit out to save memory, select new, and let's start making our last 2 bars here. So here, this is going to be relatively quick. We're going to make it the same way we did with the crank. So I don't know why I used the origin in this situation, but that's okay. I'll keep these horizontal. I'll define those in a second. Just make all these circles here and then make my slots. You'll see that I'm doing this all without giving much of a care for what the dimensions actually look like, because that's what I'm going to address after they exist. So first, most importantly, since these are already horizontal to each other, I want to make this equal. And I want to make these two also equal. And here I will now define what the distances are going to be. So center to center distance here for support number 1 is 211 millimeters. That's going in here. So that's been set now. It says 8.32 because I was a fool and I didn't change this to MMGS. So now I'm going to go select that, go back into editing sketch, and you'll see that it is showing it correctly now. Next I will change these diameters here. So outer diameter is 19.66 millimeters, and inside diameter is going to be 9.83. That's all the way in there. Now it's time to fix up this slot inside. This is supposed to be 12.7 millimeters. These are not the values you change. However, the value you will change is this larger one out here for when you design your own part. So I'm going to let this go now, and I'm going to exit the sketch and do what we did before, selecting extruded boss and base, the sketch, and then the correct contours that I want to use. So you can always zoom in to make the clicking a little clearer. And there you have it. Change this thickness to be consistent. Also, just so you guys know, you can also do 1/4 of an inch and it'll automatically convert it for you if you're too lazy to do the math. That's something that's built into SolidWorks and it's very useful. Let's go into wood, select pine, apply, close. There we go, we have color. I'll save this as support 1 or 2 because I am a little dumb. So I'll hit file again, save as. Change this to support 1 and I'll just save over the other one as I make it. So now I'll make support number 2. This time I'm not going to forget to change the units on the bottom. Extrude my boss and base, whatever you want to call it. And do the same thing. This time I want to make this circle outside, so you can see I'm going to put my cursor over here, align it. Once you see that center line, it means they will automatically be made with the definitions that they are going to be horizontal. I'm going to do the same thing, make it over each other. This will overlap a little, that's okay. Make my slots. You'll see that I don't really need to worry about the dimensions because I'm going to set those afterwards. So I'm now going to set the relations, set these equal to circumference, same with these guys, set them equal. Now it's just time to dimension it. So this inner distance, which is again what you'll be changing, is going to be what I copy and paste on my screen for support 2. Inner outer diameter, I don't need to repeat that anymore. I hope not, at least. I see I set that to meters instead of millimeters. That is not a cash money move, but I modify that to be a little more correct. Now the inner diameter. And lastly, this slot distance, which we're going to decrease immensely. Leave that smart dimensioning, exit the tool, go to features, and then there we go. It's time to extrude this boss. And now I get to select my contours. Zoom in. Go over here. And away we go. Edit the materials. Back to the right material. And now what I'm unsure of is actually whether I did the thickness correctly. At first glance it does look correct, but I'm just going to edit feature to make sure, and it is 6.35 millimeters or 1/4 of an inch. So I'm going to save this as support number 2. It's going to ask me to prompt to save over it because I made the first one incorrectly. And with that, we have all the parts that we're going to use to eventually put this together. And away we go now. So on the bottom right of the screen, I have some of the parts that I've downloaded off of the class website or files that are given to you by the professor. These are the brass tube, the bushing, the motor, the set screw shaft collar, and the spacer. I'll probably move some others in the future, but these are some of the parts that are given to you that we'll be using to make the assembly. So one thing I did add to this assembly before beginning is the base. I'm going to open up the base right now. We're going to modify this so that you can actually create your attachment here. So what I'm going to do here is actually first remove these holes because I don't need that anymore. But for this base, I need to make this a lot taller so you'll be able to see my part actually move. So I know that this is going to be quite long. Of course I can always hang it upside down, but I'll try to make this a little cleaner. So to double check our height, we can always reference back to our model on Geogebra, how exactly tall this is going to be. You can also estimate, or I know that at longest extension, I'll go from the longest point here to here, plus the longest point here to here. That should be sufficient for my heights. And I have those lengths here on my plates. So my two longs added together make it about 1 meter tall. So this is a very large object. So I'm going to go into this model. I'm going to edit this sketch. And then it's going to slowly appear. Give me one quick moment. And I realized this was extruded from the top. So instead of that, I'm actually going to change the feature. And the feature extrusion will be 1 meter. So this is going to become very tall now as I rotate this. Is this a realistic base for you to make? No, because this base is very small. Just you know, just for feature's sake, I will actually make this a little bit wider of a base just so we can feel a little bit better about ourselves. I'm just going to make this 1 meter out, and we'll make this about 1/2 meter across. So nothing too crazy. It's going to look a little large, but that's also because our assembly is going to be a little larger. Now we also need to remember here, the positioning of our distances between our fixed points is going to be critical. So we can choose one point arbitrarily, and this is going to be our, I should make this a negative actually. So this is going to be to the left. One point's going to be to the left 379 millimeters, and it's going to be up 136 millimeters from right to left. So I will choose my right point arbitrarily. That's going to be a cut done on this surface. And let's face this face now. So I know that my circle should be somewhere up top, because I do want to make it a little bit taller. I'll place it right here. I know that the hole for my brass tubing and bushings is going to be 9.83 millimeters. And then now I need to find XY coordinates apart. I'll first make the circle arbitrarily, and I will make this relevant to this hole. That's going to be equal radii. So now this is the correct size. And for dimensions now, I'm going to have to smart dimension this to this point, but I'm going to do it first horizontally. This is going to be 379 millimeters apart. Now this is going to be, since this is our starting hole, this is going to be fixed. This will move here. And then I do know that it needs to go up by a fixed amount as well. So I'll click checkbox here, and I'll smart dimension the y's coordinates here. This will be 136 point, I don't know why I'm typing, I'll just copy it here. So this one pushed it down, which is actually good for us. I was about to say I should have defined it properly first, but I got lucky in this case. So I'll leave this as is. I'll exit my sketch, and this will ask me to put my hole through. I think 10 millimeters is just enough to get through this. I don't think that's actually the correct dimensions. This should be, I believe, I don't think it is. Yeah, but I'm quite confident this is a 6.35 millimeter hole, so I'm actually going to modify that right now. And I think this is the feature I need to change. I think this should be 6.35 for a 1/4 inch piece of plywood. Could change, but this is just so it's the kind of realistic materials you might get. You could also go up to 1/2 inch. You could get a 10 millimeter piece, but I don't think many American companies will sell that to you. And so this is going to be my base. I'm going to save that now, and then we'll begin with actually trying to put the assembly together without any of the fixtures first, just so you guys can get a view of what it will look like. Now it's time to make our assembly. I'm going to start adding a few parts in here, and we'll just kind of work through it together. I'm going to do these parts without the additions of the tubings, because those will mostly be concentric mates anyhow. I also do want you guys to see your part together so we can make any modifications before finishing the assembly. This may be a method that not everybody will like to do, but it's sort of how my brain works the best. So I'm going to open up all of the parts that are pertinent to my design. So the 5 parts I made earlier, not that any of these are not pertinent to the design, but I'm going to open these first. I did forget the base, but I'll put that in here in a second. I'm just going to slap these in here first, and then we'll go from there. Alright, so I'll add one more component. That will be the base. My very tall base, mind you. It doesn't look too tall now it's here. So because the base is probably the... well, it's the base. I'm actually going to fix it. So I'm going to right-click hit fix. That way I can't drag this around. The first part that I added here, that's going to be the crank. This needs to be floated, because the first part you put into assembly will automatically be fixed in almost all scenarios. So here on my crank, I'm going to take that, and I'm going to start making some mates, just so we can get a general, I'll call this like a floating design. It's not going to have any of the actual connections. I want to have everything touching, and I'm just going to have it concentrically move. So I want to pick one of these parts on the crank. I'm going to make it, this is where my motor should be. I want to make that concentric. I'm not going to actually reference the distance yet because that'll be useful later. And then I'm actually going to open up my Geogebra file or your screenshot, whatever's better, so I can get an idea of what mates are supposed to go where. So in this part, I know that this hole here, I'm actually going to need to flip it, so you're going to have to think about like this part being 180 degree flipped in a sense. But this part is going to be relative to the moving circle here, so I'm going to mate those two. Select my mate option, select this inner area, and then since it's concentric, that's going to make me very happy. However, I do want to flip it, so that's why I'm going to click this button here and make it anti-aligned. So now it's flipped to look like this. I'm going to hit checkbox, and as I move this, it can move in, to me, the inside and the outside frames, but it will not move these circles if I actually change the view. These circles are always going to be concentric no matter how this moves. Even though on a 2D plane looks good, in a 3D plane they're nowhere near each other. I'm just using this 2D plane to check that this linkage actually looks okay, don't run into any other major issues. So, looking at it again from the side, I have this linkage here. It's going to mimic this kind of position. And now, I'm going to connect one of these bars here. So this shorter bar represents these 2 points, this connection. I'm going to mate, open up the mating option. I'm going to select this inside face. I'm going to select this circle as well. Make them concentric, but I will not change that other position. Rather, I will now also create another mate that puts these objects together. So now I'm going to copy that mate. And now when I look at it from the side here, I have this. So as this bar moves, you'll see what this motion looks like. Again, this view only works in a 2D view, because if I look to the side, you'll see it's not looking that great. See, I can move this in a bunch of random positions. Now, I have this in a relatively okay position. Now I'm just going to add this now. I'm going to make this mate. Now keep in mind, I'm going to make this mate concentric to the board. I do not want to make it concentric to this hole, even though it's possible, because I don't want to create too many references built on another reference. It's almost like stacking dominoes. If I want to change a domino on the bottom, the whole top might come falling down on me. So it's like that's concentric. Look at it from the side again here. And now I'm going to have this last piece. So this piece is going to look a bit like this. This can move because it's not forcing these to move. And this part will also need to be flipped eventually. I will select a mate. I will select one of the easier mates to do. I know that this point here will always connect here. The only challenge here is envisioning whether this is the correct angle, whether this is the correct alignment, or if I should choose this opposite alignment. I recognize that the shorter leg of this triangle should be connected up here, and the longer leg should be outside. So I know that the initial alignment like this would be correct. And you'll see this more in a second. So now that I have that mate, I'm going to select this inner circle, which will align with this mate, or sorry, this part, and I'll do a concentric mate right here. So see, that's all set up now. Now from the side, this does not look very good. I've seen better days. But from this angle, we have the ability to see something happen. Now I need to break the singularity. This is something I am at fault in right here. There we go. Broke that out. It's just a little bit of SolidWorks geometry. But this is my leg. And now as I turn this arm, see I kind of have a little bit of a seizure. This is generally a sign that something may not be working correctly. Note that this one was not created because that's just made by the board. It's kind of useless. It wouldn't make sense if you actually made it. But as I turn this angled part, and this will work better in a motion study, but it's going to start creating this walking motion. And it should trace out the circle that was done on my Geogebra file. It's not going to be perfect because, again, I did try to line up the holes the best I could, but it should get the job done, okay? Now, just for my own sanity's sake and a little bit of clerical work, I am going to recolor some of these. I'll do that off screen just so it's a little easier to see what I'm referring to. Okay, so instead of actually doing off screen, I'm going to show you how you can actually change the appearance of your parts on screen right now. So here, I'm going to change the coupler. I'm going to right click it, and then there's a button here for appearances or copy appearances. I'm going to click appearances, and I'm going to click the crank. And on the left here, it's going to switch my whole front facial screen, and then I'm going to have the option to start modifying its appearances. So what I'm going to do, instead of going to advanced, I'm just going to go straight to color. I'm going to make it a different color for it to be more clear to you. And so for the for the crank, which is what I have selected, I'm going to make it a pretty bright green. You can also make it custom colored here, but let's see how much of a neon green I can get. Maybe I'll just keep it a dark green. It's a little easier to see, I think. So I'm going to just click checkbox, and now it's easy to identify which one is your crank. Next, I'm going to look at the coupler and the follower. So the coupler I will make blue, and the follower I'll make it red. So I'm going to right click here, the follower, select appearances, do just like I did with the crank, and I'll try to make it an obnoxious red. Check the color blocks, and then let's see what's the most obnoxious red I can give it. That makes it obviously red. I think this should be apparent that it's red, at least compared to everything else. And then lastly here, I will now select the coupler, which will be blue, and appearances, plate 1. Here I will select color, and let's try to do these don't show up very well, but this is a nice dark blue. This should be very apparent which color is which now. We'll select that. For these here, I will just keep these their natural pine color. If you feel a need to change it or modify it on your own, or when you make yours, that's going to be up to you, but do not duplicate these colors. So now I'm going to give it a quick spin, just show you it's still working. Did not break anything by changing the appearances, just the appearance, and we'll continue from there. Now that we have our appearances and the general gist of our assembly looking pretty well together, we're going to start adding the essential materials that we want to put into this. The first will be the motor itself. So the motor, I will not put screw holes for it in this model. However, the motor will be attached on the back side of this assembly, this face, and we'll peep through. It will have some attachments. It'll connect to the crank. I'm going to first put that on there. You'll see that we'll need to make some modifications to the crank afterwards, but I want to first put the motor in before. And as we start to add parts, we'll realize the pecking order of how these linkages and couplers should be put on. So first I'm going to insert a component. I will be adding in the motor, which is a file that is given to you. And I'm just going to click arbitrarily on the page to add it. The important part of having this motor in here is making sure that when you put it in, this hole is going to be concentric with this hole on the board. And then I'm going to push it in a little closer. You'll see that it'll stick through the hole here, and that it won't get past this part. So what I'm going to do here is select this hole. I'm going to make it coincident with this plate, so it's as far up as it should be able to go. You'll see that it's stuck there, and it comes out here. To me, this hole should be made larger actually, so that you can fit the entire part of the motor in, because there are holes inside of the motor to attach it. I'll actually make this transparent really fast just so you can see what I'm talking about. There's these holes here that are meant for M3 screws to attach the motor to the panel. So I'm actually what I'll do is I will measure the outside of this cylinder. It's a radius of 0.24 inches. So what I'm going to do is actually edit my part, so I know it's 0.24 inches. I'll make a note of it on my notepad. Motor shaft max D is 0.24 inches. And I'm going to get out of the measuring tool, change this transparency back to normal, and I'm actually going to select edit the part. So you can edit the part in the assembly, which I think is something that's really great. I think it just makes life a little easier for you. And then I'm going to look at this. I'm going to edit the sketch for this cut extrusion. I'm going to make this 0.24 inches. Now one problem here, actually that was the radius, so I need to double that. That's going to be 0.48 inches. See, I noticed it got smaller. Be a little smart about my work. And then unfortunately, because this size changed and I fixed these two hole sizes, this one will also be a little too large. So what I'm gonna have to do now is actually select this hole, delete this relationship, and then actually use Smart Dimension to define its own size. And this should be actually the outer diameter of the tubing. The inner diameter of the tubing, which is 9.83 millimeters. So I put that hole. I'm gonna check my dimension, exit my sketch, take a quick gander at what this looks like. I'm gonna exit out of the edit component button, and I should be good to go. Because this mate is a concentric hole, changing that diameter shouldn't change the actual parts itself. What I will change is I'm going to go into the mate and I will delete this coincident mate because that's not what I want. Instead, I want to make this panel coincident with, and I'm going to have to slide in a little tighten here, this wall. So I should have clicked mate first. That's my fault. I'm going to click mate. I already selected this face, and I'm going to select this back panel of the board to be coincident. Now this motor is pushed all the way up. I'll look over here, you'll see that it is a very clean fit with the shaft in here. And now you're ready for the next step, which is going to be to put on the crankshaft collar, which is another part given to you. I'm going to save this as well because that's a good practice. Now that the motor is on your base plate or the base, you're going to now add the wheel hub, which is another part given to you, into this model. So here I click Control Open just to show you what it looks like. This is the wheel hub. You will use a set screw to attach your parts, and these holes will attach to your crank. This attachment to the crank is something that we'll have to actually modify the crank to do. I'll demonstrate that after I attach this into the assembly. So I'm going to click Insert Components, and I will select the wheel hub. Click anywhere arbitrarily to place it in the picture, and what I will do now is select a mate with concentricity between the inside of this wheel hub and this bottom semicircular part. Now you notice that this went in backwards, so I want to change the mate alignment to flip it. So now I notice that it flipped in the correct direction. I'll hit checkbox. We can't find the part, it's stuck back here unfortunately, so I'll need to make this part transparent to go find it, and I'm going to actually quickly drag it out and change this transparency back. That's something that will happen sometimes because of my arbitrary placement. So now that this part's out here, I do know from experience that this wheel hub is not meant to go past this divot. Essentially that allows you to put a set screw through this hole that's highlighted onto this flat bar of this motor shaft. This is called a D-shaft motor. You can guess why it's called a D-shaft motor. So I'll try to align it the best I can, hope it looks good, or for posterity's sake, I can actually just select, now note I'm doing this arbitrarily, this back end of the motor, not the motor, the hub, and then I'm going to have that cap out right here. I don't want it to go any further than that. Now this is a little transparent, you'll see that the set screw will be able to fit inside of this as well, so this will be my arbitrary designation. Select that, hit OK, and now this should be quite well defined while still being able, I believe, to spin. Let me double check that it's still able to spin. Right, it can't spin because of it's okay. I'm not going to spin the motor anyhow, but this can still spin, which is what we're going to use later when we attach the crank to this. Now you notice that these holes are not the same dimension as the crank's holes. When I line up this crank, put it face to face here, you'll notice that there's no way for me to actually attach this through these holes. So I'm going to need to open up this crank model and make it the size of this outer diameter. So I'm going to make a note here. This is a new section. I'll say this is the crank to hub measurements. I just like labeling it so I know what I need. I'm going to clean this up as well. So crank to hub, I know that the hub diameter or outer diameter is found by clicking evaluate, measure, and then this outer diameter. This outer diameter is going to be 1.1 inches. So that's what I'm going to need to change this outer diameter to. And then I'm going to need to align these holes. The holes are going to be 0.12 diameter holes. So inner holes. Again, I'm arbitrarily naming them. I could also say these are the screw holes. But these are going to be 0.12 inches. And it seems that they're spaced out every third. So this will be 120 degrees. I'll use probably a revolve sketch for that. We'll go through this together right now too, so don't worry. Speed through this if you already know how to do this. Everything else should stay relatively the same. So now I'm going to edit this component. Well, first I'm going to click out a measurement. I'm going to right click my crank and then I will edit my part. So now that I have this open, it may be distracting for you to have all the other parts. So if you'd rather rebuild it on its own, that's entirely up to you. I'm just doing it on this assembly because it's accessible. So here, I know that I'm going to want to create a larger hole. Now I'm going to go in here and then I'm actually going to change the only feature on here, this extrusion. I'm going to edit this sketch. Upon editing this sketch, I'm going to modify this outer diameter, which is also going to modify the outside of this. So before I do that, see, I'm kind of need to take a step back. You know, I also make faults too. I'm going to select this outer diameter, this one as well, and I'm going to destroy it. I'm going to delete the equal sign. So that way, when I change this outer diameter, this one won't change. But because I broke that, this outer circle no longer has a dimension. So I'm just going to quickly dimension it because nothing changed. It's already 19.66 millimeters. That's the outer diameter of the tubing. And instead, I'm going to smart dimension over here that it needs to be 1.1 inch. So this says it'll make it driven, and I think that's because I should have edited this instead of redimensioning that. I apologize for my mistake. I'll make this 1.1 inches. Now it's the size of that hole. Exit out of smart dimension. I'm quite happy with that. And now I'm going to need to add some holes in here. Now first I'm going to exit this sketch just so you can see the component. Now this is nice and aligned with this size. And I'm still in the edit component phase, so now I'm actually going to create a sketch on this surface to put the holes in. Now putting the holes in, you might ask, should I actually find out where the holes are and build it on top of it? The answer would be no. I'm actually going to need to create a different measurement, so I'm going to exit out of this edit component section. And what I do need to find is the distance from the center of this circle to the inner radius, or the inner circle here, because they do share that same concentric point. So I'm going to click my measure tool. I'm going to click this outside sketch line, and I'm actually going to select this inside circle. And what this measure tool should show you, if I pull it over here, oh yeah, sorry, I have an extra part here, this face that I need to delete. So now this is going to show me some distances. This is where some math comes into play. So in my notes here, I'm going to make a note that I know what this inner hole radius is. And then I also know, there's also an easier way to do this. I'm just not going to do it right now because I want you to figure out how to use the tools you have around you. So I know that this hole, this minimum distance, this radial distance is 0.27 inches. I'll say radial 0.27 inch. And then I'm going to clear my selections. I'm going to find out what the radius of the center hole is. So this diameter is 0.25 inches, or inner radius will be half of that, which is going to be 0.125 inches. That means the sum of the radial and inner radial portions will get us to the outside of this circle. So I'll show you that again actually right here. Or actually no, this brings us to the closest outside point. So then I need to also add the radius of this outer hole. So I should say this is inner hole's diameter. So knowing the radial plus inner rad plus inner hole's rad is going to be equal to the total distance from the center for crank holes. Now you can go back and rewind that, try to follow me if I lost you on that, but we're essentially using the parts we're given to measure out how we're going to find these hole centers. So this summation will quickly, if I just do it really quickly here, should be 0.395, we'll make that 0.3, 0.4, 0.455. If my math adds up. Just because I'm bad at math, I'll pull up a calculator. 0.6 plus 0.27 plus 0.125. This should be a 0.06. So see, I make mistakes all the time. 0.06 plus 0.125 plus 0.27 is 0.455, which is what I have. So now I'm able to leave this measuring tool, or at least close it for the time being, go back into editing this component, editing this part. I will create a sketch on this face, and I will start adding 3 holes arbitrarily. Actually, 1 hole. We're going to try to do this intelligently today. And then I'm going to start adding some dimensions. So I know this hole should have a diameter listed here of 0.12 inches. But where should these holes go? I know that this distance from this hole, so I still have smart dimension on this center, to a view from... Now that I think of it, I actually can't get the center hole here because I didn't create it on this plane. But hold on, give me 1 second. Let me see if Smart Dimension lets me do this. Okay, Smart Dimension still does let me do that from center to center. So I know this is going to be 0.455 inches. So now this is the correct distance out. The last thing I'm going to need to do is create 3 of this. So what I'm going to have to do is create a pattern to do that. Now what I can do is on the top of my screen, you'll see by my mouse a circular sketch pattern. So I want to create a circular sketch pattern. I want 3 of them, or not 2, 3. And then I want this to be, I believe it should be out of 360 degrees, it should have equal spacing. And the entity I want to pattern is this circle. Not along this radius because it's asking me to select a point. But what I'm going to need to do, and I actually don't always remember this, is just pick where the selection point is. So I'm going to get rid of that point. I'm going to try to select this center point instead. That's not what I want. I want this hole instead. Will let me select this point is actually my main point of concern. I can also select this inner radius because it does share concentricity. And now I just click checkbox and it'll give me all 3 of these circles defined. Now that I have that, I'm going to exit the sketch. I'm going to go to features. I'm going to click extruded cut. And then this should be, I believe, 6.35 millimeters, just like everything. I can also reference my notes. Did I put in the notes? Oh yeah, no, I didn't put in my notes, which is something I will add. 1/4 inch wood thickness is equal to 0.63, not 0.6, 6.35 millimeters. And click checkbox, and now I have my holes. I'm going to quickly make an addendum to myself as I actually spaced this bushing incorrectly. So I'm going to pull up the mates that are relative to this part. I'm going to delete those and then go on from there. So let's look at the bushing number 1, and then I'll select the mates in assembly, and I'll actually just edit this coincident part of the bushing, edit this feature, and I'll flip its alignment. Now this is good. It did break some other things, but that's okay. Those are what I will need to fix in the future anyhow. So now with this bushing, we need to change its coincidence here by deleting that. And let me see one more. Okay. Yeah, now accessing the bushing becomes a little bit of a problem. I'll have to make this, I'm actually just going to suppress this part and pull the bushing out itself. Now I'll unsuppress this part. Apologize for the potential confusion. Then I will try to mate. Oh, that bushing disappeared. Oh, that went very far places. So finding that bushing, I'm going to pull it back out. Bushing, where are you? I would like to mate it with this outside edge. Clear selections. I do want to mate this Can I pull the bushing out? No, I can't. Something else is locking in place. So you guys are seeing me struggle with this a little bit. Now my solution here is actually just to delete the bushing and re-add it because I just did it so poorly in the initial place. Tried to fix it, saw it wasn't worth my time as I could have just added it in the assembly again and remade it. So here I will first make this coincident with this back face because this will allow us to put the lock on it. Make that coincident, and then next I will make the outer radius concentric with this inside radius because it should match that size. Let it go and we should be good to go here. So if I make this transparent, you'll be able to see the bushing go through here, which means it's effectively put in place. All right. Next, this means I've also forgot to connect one item here, and that's going to be another bushing from the coupler here over to the inside. So I'm actually going to break one of the mates that went between these two plates. This went between this spacer and the coupler. I'm going to move it back, and I'm going to insert two components. I'm going to insert a bushing as well as a spacer. So put these two in. First thing I'm going to do is put the bushing inside its correct position. So I'm going to outside radius with this is going to be concentric. Okay, see it's concentric here. Hit a checkbox. But I will need to make this face coincident with this outer face. So I'm going to highlight that, select this, and then flip the alignment. And there we go. Now that this bushing is inside, I can now take this spacer and I'll add all the mates to fix it in. You should start to be getting the hang of this now. I'll make it to concentric to... I'll just make it concentric to the spacer next to it, actually. This is where, actually, that's a bad mate to do. So what I did, I was almost very lazy, and I almost selected a different mate as my basis, but if that mate ever changed, I would probably be in a pretty bad place. So I'm going to fix this transparency again. Instead, I will mate the spacers to each other so they essentially make one larger bit. So I make this coincident, and then I will also make this concentric with its spacer right next to it. That way they are going to be, call them buddies. All right, that's there, and then I'll move this over because I do want this face, not this face, to be connected. So you'll see building the assembly does take quite a bit of tedious work. I wouldn't say it's very conceptually difficult, but it takes, I got to think about it once in a while and be like, okay, is this the correct way to attach it? So now what's left to do is actually attaching this face and making this coincident with the face of the spacer. So after I make that selection, I can make this transparent really quickly. I'll see that my bushings do not hit each other, which is important, otherwise this would obviously pop out. And then I will make this not transparent anymore. You can also go select the actual part here and it changes transparency as well. You don't have to right click it like I've been doing. So I'm going to save this, save my work thus far. There we go, it's saved, and I'll look at it from the side, make sure none of my motion is broken. So now as I'm turning my crank, this is going to be important for the motion study later, you'll see that it is indeed moving. And still fixed together. But now we're going to have to add these three other parts. So I guess I'm going to just keep on working through it. Feel free to play this over and over again if you want. Skip back, skip forward, play me at multiple times speed. I'll use this to try and put it all together. You'll see me succeed and fail at the same time. So now I'm going to look at this from the side view again and look, okay, where's my next point that I want to manipulate and start mating? So to me, I'd like that point to be right here, this point right here. And so I'm going to add another bushing and spacer. So remember, bushing and spacers will come in pairs. One bushing, one spacer coming right up. And also, if you're a little more diligent than me, you can actually go over here and rename these bushings or rename these parts inside of the assembly so you know what connections are where. I'm going to put this bushing inside of this concentrically, mate here, and then I'm going to also add another mate, not that face, but with this wall connecting to, well, it's coincident with this face. That makes me happy. And then I will take this spacer. I would like to mate this spacer coincidentally to this inner edge. So that's concentric. And then lastly, I will make sure that the wall itself here is going to connect here. So you'll be doing that a lot. And this is going to need to be connected to this part, because when I rotate my crank, you'll notice none of these parts overlap. But where the connections are. So I could actually flip this if I so choose to connect this on the other side, which is something I'm actually contemplating doing right now. By connecting on the back end, I keep my assembly much closer to the inside. My center of mass is not too far from the center. So actually I'm going to do that. I don't think it's never a good thing to realize you could have done something better and not to act on it. So here I'm going to edit this feature and I'm going to flip it. I'm going to flip my alignment. So it's going to break something else, but that's okay because we can go and fix that now. So I'm happy with that concentric part, and then this coincident mate that I have, I'm going to edit this feature. And instead of this face of the plate, I'm going to try to use this face of the plate. It flipped itself, so now I'm going to flip that, and it should be there. When I move the spacer, it'll become much more apparent. Actually, I'm going to change this transparency so you see the bushing is in the correct place. And now I'm just going to flip the spacer over. So I can open up the spacer on this side menu. I'll click Mates in Assembly. And then I will I'll modify this coincident mate. So now, instead of this mate, oh, that is not what I wanted, but I'll just refresh it. Now, this is the mate you will see. And so I'm going to be building this inside the same way this crank was built. So to do that, I want to connect this to this point. So I'm going to add another, you guessed it, bushing and spacer combination. And again, the next few minutes will just be me putting this together and reasoning through how I do it. So if you're already an expert at this, feel free to skip ahead. So now I'm going to add this spacer. I'm going to make it concentric to this part, the inside of this support. And now we'll make it coincident because I know it's going to go on the other side. I'm going to create a mate from this side to this part. So now when I move it later, it'll look much cleaner. What's missing here is my bushing, so I'll create a mate of this inside part to the inside of this area. Then I will also have a tangential point from here to here. Or not tangential, coincidental point. I'll just flip that alignment for cleanliness. Very good. So now that most of this is good, I just need to connect the spacers. So I'm going to mate this spacer, the inside of this spacer, with the inside. Actually, I'm going to make this board transparent in a moment. So apologize for the notifications. I'm going to mate these. And then I will then make coincident as well. That way we are set to go. I apologize again. I did not close all the tabs, but they're now all closed. All right, so now that should be not component view. That was a mistake. Click mate, select face, and then select face. Make them coincident. This looks good here now. So now this alignment means as I turn this crank, Nothing's been broken still, but we have most of the things in. Okay, just a few more connections to make. Knowing this position here is also very important because we will later add the spacers and the bushings to make this happen. Okay. Instead, I would now like to change my focus to this point right here, connecting the follower to the coupler. So I know I'm already going to need 2 sets of bushings and spacers because of each connection. These combinations are very strong. So put 1, 2, and then let's just add it right now to save ourselves some time. I can also copy and paste it. I want you guys to see everything I'm doing. So it's bushing, spacer, throw it in there. All right. So on the coupler side, first thing's going to be the bushing mate. I feel Australian talking about all these mates. Bushing mate will be concentric. I'm just going to work on it now. I think you've heard me talk about it enough. One quick note is when you do select something to mate already, that part will go transparent, which will allow you to click through it in certain tight situations, which is what I try to utilize there. Note for each of these pairs of bushings and spacers, I try to make it relative to the actual part that it's connected to, in this case the follower, rather than anything else. So I selected that part, which makes it easier to select this face for the coincident mate. And now, all that's left to do is connect spacers. Now this will be the concentricity of the spacers themselves. That's concentric. Lastly, these parts will mate coincidentally. Right, now that's in there. One part I did not take into consideration or modify in the design is this endpoint. This endpoint I kept as a circle so you can kind of see in baseline how I did it. You can come back, fill it up, make it whatever you want, because this is going to be your contact point with the ground. So now what's left to do is put this attachment here as well as through here and go from there. So I'm going to attach this follower to its support that we had made. Do another set. I'm actually going to, one second. By clicking this pin, I can actually keep adding things until I'm done with it. So I'm just going to add enough bushings and spacers to kind of go for a while. So I think I need 1, 2, 3, 4. I think I need 6 more bushings. Maybe I don't need all of them, but we'll go from there afterwards. So now on my spacers, 1, 2, 3, 4, 5, 6. Now that we've gone through most of the other parts, I feel comfortable to speed up a little and not narrate myself as much. Just back to work we go. One benefit I do have here is none of my parts will run into each other. If for some reason your parts are coinciding with each other, that's something you'll have to address, then your order becomes much more critical. But in this case, I know none of my parts should run into each other, so I have a little more flexibility and freedom when I'm selecting this. I also said earlier I would do something that I haven't done yet. I'll do it in a moment. I'll choose this spacer. You're the lucky spacer of the day. You're concentric. And now you are going to be mated coincidentally. I'm also going to pin the mating thing so I don't have to keep clicking it. What I would like to do though is make this base transparent. So I'm gonna open this drop-down menu, find my base, which for some reason I'm having difficulty doing. You guys probably already seen it, and I'm gonna hide it, just to make my life a little bit easier. And now that I've gone through enough, don't think it'll be too unclear. If you're here and you're confused at what I just did, just skip back and realize what the base is. So here I'm going to make my bushings on the coupler. I'm going to minimize this as well. Sorry, I closed the history and closed the... Oh, there we go. I don't need that. How do I close this? I already forgot how to close this. Just hide, did not want to hide that. That was a big mistake. Not too sure. Anyways, I'll just ignore it for now. Selected that. I like to concentrically mate that. Flip its direction. Make your life a little bit easier. Then select these. That's going to be coincidental. And spacer time. Ooh, got that in the way. Right, I never made that transparent again, did I? Sloppy. So hopefully seeing me work through this is a benefit to you guys. Definitely let us know if it's not. That's there. Good thing is I can flip this. I realize this does not look very good. I can flip this whole part on its own. I might have to break. Actually, I don't have to break anything to do that, which is really nice. Let me first exit out of this mate and make this transparent. There we go. Life made better. So I'm going to go back into mating. It should still be pinned, which it is. This will be made coincident. Actually, no, I should not do coincident first. I should do concentric first. Guys are going to be concentric to each other. Which is great. And then I will misselect this face and mate it with this face. And what happens is it's going to line up like that. I will flip its alignment. Tell me some things were reversed to make this possible. Let's see what it is. I don't like that. I'm actually going to flip this and then delete this mate. I don't like that. So what I need to do is I actually need to flip my orientation of this instead. So this bushing is right here. There we go. It's bushing 12. So the mates this has need to change. So I flipped this mate. Or I edit it. Delete the face on the support. Make it this one so it reverses itself. Go from there. Now this spacer needs its mate changed as well. That's not listed here. Go in here, mates in assembly. Should be this one. Edit this feature. Delete this. Make it this one. And we are good to go. Save that. All the other mates should still be fine because those are concentric. Select it here. Make it coincident. And there you have it. It's moved back. Lastly, what do we need to create? We need to connect these two bad boys because these two bad boys both go to the same fixed position. We just need to add a spacer and bushings inside here so that it's able to connect. And then we'll need to make enough spacers and bushings so it goes through the wood as well. So to do that, we are going to put a bushing in on each side still. All bushings are going to be in here no matter what because they are very useful in reducing the amount of friction between the part and the brass tubing, which allows for best possible movement. Let's go here, one more bushing, go in the other one. I'm gonna flip it, the alignment. Gonna select you. There we go, now we're together. I'll put two spacers in here. I think that should align pretty cleanly. We'll see in a moment if that holds true. make that concentric, and then make that coincident. And one more time, making this concentric, and then coincident. You'll see the fit is very clean on this side. I'm very pleased with how that looks. And what I need to add now is going to be a bushing inside of here. Very good. And then I will make the face coincident. And now what I'll have to do is add spacers that go inside of here until we get enough. And so to make sure the spacer, actually you don't actually need to add bushings on this opposite side. I am curious if I could, but I don't think I need to account for space. Rather, instead, I will just take all the extra spacers I have here, make it coincident to this radius. And this is the one time where actually I'm going to have to undo the transparency of this part because I'll need to reference the circle on it. So open up my mates, make it concentric, not to the bushing, but to the wall. And because we're going to put it flush, make sure to mate this to the wall. Now we'll just keep doing this until we bring it up to this part. So I'll make it, this one I'll connect to the spacer. And then here it's coincident again. And I think I can fit one more spacer in here. If not, then I will have to modify one spacer to fit this gap. So actually what I'll use, instead of physically testing out, I'll use the measure tool. I can use the measure tool, I'll select this face, as well as this face. It tells me that the minimum distance is 0.21 inches. And I know from measuring my spacers now, that my spacers have a minimum distance of about 1/4 of an inch. So I'll need to edit a spacer to fit inside of this gap. And then I will delete this extra bushing because I miscounted. And there you have it right now. If I put this right here and I start moving this crank, oh, sorry, I'll start moving this crank, everything starts moving. And there you have it. Your assembly is sans one spacer here, as well as the tubing is basically done. So I'm going to save my work here at this point, rebuild and save the document. We have a few more important details to get through before we get to the motion study and completing this. But first, I'm going to open up the parts of the spacer as well as the, let's see, I think it's the spacer I need first and then the brass tubing. So I'm going to open up the spacer and the brass tube. These are the parts. The brass tube, we need to cut it to length essentially. The spacer, we're going to make ourselves a new one. Now your options are either to use configurations, but to make it easier on you guys, I'm just going to save it as a new part. So I know that inside of my, oh boy, thanks Steam. I'm going to have to kill a few things on my menu in a second. Okay, so I know that with my assembly here, I can measure out, using the measuring tool, the distance that I need to cover between this bushing and this spacer. So it would be difficult in real life to get this spacer without 3D printing, but since we're using SolidWorks right now, I'm using this to fill in the gap. Maybe if I carefully considered other factors before doing this, I would have avoided this problem, but I didn't. So here we are. So I need this to be a 0.21 inches in diameter. So I'm going to minimize this. And then I'm going to open up my spacer and I'm just going to edit this extrusion. So I'm going to change this feature to 0.21 inches. It's a smaller spacer. I'm going to save as, not save, to replace the file. So I'm going to save as. Now I want to save as a copy. So I do not save it as this top file because then all my old spacers will change. Rather, I want to save as copy and continue. So here I will do spacer and I'll add a dash I think I could put spaces here, but 0.21 inches. There we go. And so now I'm going to go back into my assembly. Hopefully my parts did not change. We'll see right now if I've broken it or not. This is the moment of truth. I may have selected the wrong option. If I did, I'm going to have to go back and cry a little bit, but load a little bit because I can't afford a 2080 Ti yet. It's supposed to be after grad school. Maybe it won't load at all. We'll see. Give it a little second. So I opened it up and turns out that I did actually do it incorrectly. I need to go back to the spacer, open this bad boy up, and say, okay, I'm going to change your model. It's going to edit your feature, put it back to 0.21 inches. So this is going to repeat from what I did before. Made a mistake. I'm going to try to do my best I can to remedy that. Save this as a copy and open, so I will not change references. And then I'm just going to call this short spacer. Make it very clear to myself. That way now that it's saved, I'm going to close this file. Save change to spacer. Nah. I will keep my... Actually, hold on, I'm going to cancel. Let me think about this. Yes, I would want to save the changes to spacer. And now I can go into the assembly. Well, give it a second to get there. Gotta load it. There we go. So my assembly is open now. Let's make sure I didn't screw up the dimensions again. It looks like I did, which is genuinely tragic at this point. So I'm going to open up this part. For some reason, I did not save my changes correctly. You at home can ignore this unless you made the exact same error as me. But I'm going to save this file, go ahead and close it, and I'm going to rebuild my assembly. So now these are all fixed properly. Now we're back where we are before I decided to mess some stuff up. So I'm going to take my short spacer file. I'm just going to add that in here now. So I will mate the interface to here concentricity, and then I will try to do this coincidentally with this outside area. So it shows there is a little gap. It wasn't perfect, so when I did the measure, I should have measured it to a larger length, but I'm going to keep it with a little gap rather than infringe on the other parts right now. So there's my spacer, and now I'm going to have to figure out the distance for my brass tubing. So I'm going to exit my mate, and I'm going to use the measuring tool to see exactly how long my brass tubing should be, and then how I'm going to add the lock nuts at the end of that. So I'm going to go to evaluate, open up the measuring tool. I'm going to select the outer face of the bushing and then the outer face of this bushing, and it'll give me the minimum distance of 1.09 inches. So now I'm going to open in on my notepad. I'm going to check for my brass tubing distance. I know that min distance is going to be 1.09 inches. I also know, because you've listened to this video and you listen to me talk, that I do have an item that is going to connect on both sides of the brass tubing, and that is actually going to be the set screw shaft collar. So I'm going to copy that and put it in my files. Turns out I already have it, so I just missed it. I did. I'm just trolling apparently. So I have a set screw shaft collar. This is what's going to go at the end of the collar, and one's going to go on each end. So I'm going to evaluate this by measuring the distance from this edge to this edge. It has a 0.28 inch minimum distance. So now with one on each side, that means I'm going to have to add 0.28 inches on both sides, which means my total brass tubing length is going to be 0.56 plus that is going to be 1.65, I think. Yeah, 1.65 inches. Double check so you guys don't think I'm pulling a fast one. We pull the calculator over from before, clear it, get 1.09 plus 0.28 plus 0.28, 1.65 inches. So now that I know that's going to be the length of my brass tubing, I'm going to minimize my assembly, open up my brass tubing, and I'm going to change my feature length because almost all of them are going to be the same except for a few. We'll address the unique ones later. So this is going to be 1.65 inches. Remember, it's fine to be shorter or longer because it's a set screw shaft collar. We just don't want it to be too long because then it might get in the way of the other parts of our assembly. So I'm going to open up my assembly, and I know that I'm going to need a tube here, 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 and here. So I have 4 points where I need this brass tubing. This point up here on the 2 fixed points, we'll need to address it differently with a different length brass tubing. So I won't add that right now. So I insert my component, my brass tubing. I'm going to pin this because I need 4 of them. 1, 2, 3, and 4. Now that I have my 4 brass tubes, I'm just going to stick them in. So I'm going to hit mate. I'm going to make this concentric with this part. And all I need to do after that is actually I'll make it a little easier on you guys and show you the faster way to do this. Is you actually add 4 of the shaft collar. I mean, sorry, not 4. Yeah, I need 2 of them, so you need 8. So I'm gonna add the 8 shaft collars first. My bad. So by adding 8 of the shaft collars, you can add them into the assembly and just bring the brass tubing to the outside edge of the shaft collar because we did the hard work in the measurements before and we just need it to line up. So here are my shaft collars. I'm good with inserting components. I will mate this first concentrically with this part. And this is when you have a little bit of leeway in being a little lazier. Now, unfortunately, I need to find my shaft collar again because it fell inside. Hopefully if I move oh, it's concentric, it's not going to come out. So I goofed a little bit inside of here. I have to make a lot of these parts transparent to find it. Is that it? Can I pull you out? Almost. So I just need to make this part transparent and I should be able to access my shaft collar. There we go. Now I can go back, right click all this, fix this transparencies. Try to avoid that problem when you do it. That was a mistake on my part. Okay, so now I'm going to mate this part to the inside face of the shaft collar. And voila. Now I have one on this side. I'm going to take my brass tubing and I want that face to be the same level as this, so coincident. And I'm going to hit checkbox. Now I know where my shaft collars go on the other end. So I will start doing that. I probably won't talk too much while I do that. Maybe do one more. I'm going to change this to transparent to make my life a little bit easier. And it's time to start mating again. You'll see that that's quite a good fit. Very pleased with that, and we'll let that go. Perfect. Let me just check one thing from the side. Are these screws going to get in the way of each other? The answer is no. I like that. This pleases me. So back to mating. See, I made that same mistake again. Where Control Z comes into play. Pretty sure it's in there, so I have to go find it again. That was a mistake. I should not have done that. Oh well. Oh, nope. Turns out I Control Z'd enough times, I think. Let me double check. I have 1, 2, 3, 4, 5, 6 collars. Yep. That was fine. Did not need to do that. It's okay. All right. So what I'm going to do actually is select the face first. put that on the bushing and then mate that. I think that is definitely the smarter approach to avoiding the problems I ran into just earlier. Notice on the same side, flip the alignment. Good. And then I will just do concentricity now. I'm going to do all these set screws first before I do anything else. Find that part. Is that line well? Good. Okay, you're concentric. Put your brass tubing inside now. Pick an arbitrary one for it to be concentric to. And then select both faces for you to make it coincident. That's another one done, and now just a few more, and then we'll be scot-free on the brass tubings until we look at the... Well, that is until we look at this top one. But that's just measuring and making yourself a unique one. It's going to be that face here. Ah, I selected the wrong face on the shaft collar, so I will select a proper one now. No, sorry, I'm experiencing a little bit of lag here. Zoom in. I think it's this one. I actually do not recall now. We'll see if this one gets weird or not. Yeah, there we go. Ooh. And then let's see, where am I going with the last set? This one. So select the faces. Turn it around. Going right there. Make it coincident. Now I'll make it concentric. All right, one more shaft collar right here. That's gonna go here. Yep. Selected the wrong face, just gonna delete that, select the proper face, and make it coincident. I had the wrong, there we go. So I'm just kind of looking across my screen. I know I kind of have an idea of where I'm looking for my parts. So if you don't see it, you can go back and play it in slow-mo. If you're already good with this, don't worry about it. Just speed through it. So now I have everything on in here. And I'll put my brass tubings in. All right, and with that, you'll notice that SolidWorks is pretty intelligent when it runs through this. You have most all the parts in here. Lastly is this top little bit. And so what you can do is exit out here. I will first add my shaft collars so we can just measure the distance I want to use. So shaft collar, pin that, drop 2 of you in there. Perfect. And now, just open up my mating. I will put one on the outside here. Flip it. And make it concentric. And this one, keep in mind, needs to go on the opposite side of this piece of wood. So I'm going to close my mating. And I will make this not transparent, I'll make it opaque. And lastly, I'll just mate these sides. Flip it. And make it concentric. And so this last section here is where we're going to measure this brass tubing, put the brass tubing in, and call it a day from there. So here I will open up Evaluate, my measure tool, clear all previous selections in case I had any open. And I will take the measurement of what the minimum distance is here, 2.68 inches. And also go max distance, see if there's a difference. Nope, 2.68 inches. So max distance, 2.68 inches, put that in the notes because what we're gonna do is save. And then open up the brass tubing we have and make the longer brass tube. Put that in there and then we'll have completed our assembly and move on to the motion study. Brass tubing is here. Edit the feature. Remember, it's 2.68 inches. You can put that directly in there. It'll convert it. Now what you need to do is click File, Save As a copy and open it. I'll say long brass tube because there's really the only one here. Close this up. I do not want to save changes to brass tube. And then I do want to keep the changes in my assembly. I'm going to restart the assembly or refresh the assembly. It seems like I should have saved it. It seems like I'm not an expert enough at what I'm doing right now. But I will first edit this part, shorten it to what it needs to be. So click this and edit this feature. In my notes, I still have the total length as 1.65 inches. Put that in there. Finish editing my component. I'm pleased with that. Now I will insert my longer brass tube. So I insert that part. Now put the mate, concentric, add some faces. And we are good to go. You should pop up on the other side. There we go. Your brass tubing's in there. So if I close my mating and I look at this from an isometric view, you'll see everything's been connected as it should. Some of these bars are actually not where they should be, so I'm going to look into this right now. I think I needed to fix... I'm going to open this part. I'm actually just going to fix it here. Close this, save the changes there. Now the assembly should look normal again. So the brass tubing's still in there. I'll look at it from the front view so you can get a good look at it. All the brass tubing is inside of there, the shaft collars and whatnot. And as I turn this crank, it's still moving. We're set to go. And if you've gotten this far with me, congratulations, you're almost done. I'm gonna save that again. And now we'll get ready to go on to the motion study. I'd like to begin by first congratulating everybody who's completed their project up to this point or their homework assignment. Here we're going to look into how to actually perform the motion study to create an animation. So to do a motion study, for those of you who have not taken 152 or may have forgotten 152 like me, yes, I did undergrad at UCI as well. We're first going to go into the motion study tab. I'm going to click it again. It should pop up with the actions underneath, but I'm going to click this button, motor, and they'll give me an option to generate a motor. And then I'm going to put it about the crank, so it's going to rotate, and then I'm not going to do 100 RPM. Let's do 10 RPM. I don't have that much of a need for speed. So I do have my rotary motor there. I did not mean to take a screenshot. I meant to change my view. And here, let's take a look at playing the motion study. So by playing the motion study, I'm just having my crank move at 10 RPM. You'll notice that it's glitching a little bit. That's mostly because I don't have this on full screen and I'm using OBS to record this. Let me maximize this a little more and see if I can change my view. So auto key, I don't need that. I'm trying to see if I can just make this screen a little bit better. I'm gonna look at motion study properties. I'm gonna up this to 60 frames per second. That way when you're looking at this video, you're not gonna be too sad at least. Basic motion, we'll go 60 as well. My computer's probably gonna cry a little from this, but you know, we do this for the people. I'm a man of the people, I hope. and go from there. So motion study properties, beef that up a little. This button here calculates the motion study on the bottom. Here you have the ability to do animation or basic motion. But here I'm just going to, I can save the animation, but I do not want to rotate the model. Rather, I would like to figure out how to set my window frame, which is something I'm not 100% sure of right now. But let's set up this and let's just save animation. See if I can change the, call it animation 1. Can I save as an MP4? God bless I can. Image size, I have a very large monitor, so it's a little messed up, to be honest with you, but let's do, I have a 2680, but I have a 2560 by 1440 frame. Let's just do that. Okay, well that's, apparently it's set one. So we have that, fixed aspect ratio. Let's do the entire animation. Let's see if we can do 60 frames per second without destroying my computer. Let's see what that's gonna look like. So right now it's saving. It's actually going through the entire motion study. I'm gonna let this run for a little bit and I'll put at the end what it should look like.